Longshore drift is a geographical process that consists of the transportation of sediments along a coast at an angle to the shoreline. This angle is dependent on prevailing wind direction, swash, and backwash. This process occurs in the littoral zone and in or close to the surf zone. Deposition occurs when the wave velocity is slow or when ocean currents slow due to encountering frictional forces such as the seabed, other countercurrents, and vegetation. Much sand and silt is carried by a rolling wave and is driven up the beach by the power of the wave. This is referred to as a swash. Backwash, on the other hand, is the water that returns back into the ocean. With the previous topic in mind, the next step is to discuss what happens after a long, continued cycle of longshore drift. As rocks and cliffs continue to be weathered, eroded, and moved, it stands to reason that this material being generated will have to be deposited somewhere along the coastline. So the question is, what types of landforms are created as a result of this process? As the gradual buildup of sediment continues, beaches, spits, and bars are landforms that may emerge. One may visualize a beach to be an area that only contains loose sand and gravel. However, beaches can take place in a more complex form, as they are made up of elements within the surrounding region. Shingles, pebbles, cobblestone, and shell may all be included in the sediment buildup of a beach. Another landform that may be generated is a spit. Sand, silt, and clay from eroded cliffs are slowly transported through longshore drift and are deposited onto the coastline. A spit is an extended stretch of beach material that projects out to sea and is joined to the mainland at one end. A baymouth bar is a spit that completely closes access to the main body of water. The bars usually consist of accumulated gravel and sand and most commonly occur across artificial bay or river entrances. Should a bar or spit increase in length, a tombolo may be created in which an island becomes attached to the mainland via the bar or spit.
How does wave action affect the coastline? Waves are caused by wind traveling and interacting with the surface of the water. The strength of a wave is determined by the speed of the wind. Waves have the capability to shape the coastline through erosion and deposition. Wave action can cause great displacement to coastline beaches. Waves that begin their breaking motion far from the shore are called constructive waves. These waves construct the beach by adding sand to it. Another type of wave is the destructive wave. This wave hits the shoreline with great force, causing the sand to be pulled back into the ocean through backwash, therefore eroding the beach. The wave approaches the coastline on an angle. This causes water to move at different speeds when comparing shallow surface water to the deep ocean floor water. A bending action occurs called wave refraction. These waves shape the coastline when headlands, harder areas of rock, remain resistant, while the rest of the shoreline becomes eroded. What are the types of coastal erosion, and what damage can they do? Coastline erosion generated by waves can be caused by 4 different processes. The first is through the process of corrosion, where chemical rocks are dissolved by seawater. Its erosion is caused by chemicals and reactions within the water. The next process is called abrasion. This is where sediments such as sand wear down rock surfaces due to its turbulent sandpaper-like action. The rock surfaces become smooth because of this. The third process is called attrition, where rock particles strike and hit each other, causing fractures while the rocks continue to reduce in size. Finally, hydraulic action erodes the coastline through water being driven into cracks in the rocks, widening the gaps and causing the rock to break apart. One of the main actions of rock erosion occurs through a process known as undercutting, where rock is worn down by hydraulic action at sea level. As more and more rock is removed from the base of the rock, the top collapses, creating a steep vertical cliff.
The continual interaction between land and sea is apparent here, along the northwest coast of America. Erosion is a major force taking place. Over millions of years, significant change in the landform has taken place. This coastline would have looked a lot different. Even though the rock is tough basalt, the sea has eroded it in magnificent waves. Cliffs are formed as weathering weakens the top of the land and destructive waves crash into the bottom of the rock face. Weak points are affected the most and eventually form a hollow, called a wave-cut notch. Over time, the overhanging rock collapses and is dragged out to sea, forming a wave-cut platform. The whole process continues, and over millions of years, the landform retreats. If we go back several millions of years, the land would look something like this. First, the waves go for the weak bands of rock, then it goes for the cracks in the harder rock, forming arches until the cliff eventually collapses. Once the arch collapses, it leaves pillars either side, called stacks. The stacks are then worn away and forms a wave-cut platform. An example of this is the Green Bridge in Wales. As you can see, the future for this natural bridge will not last forever. The arch will eventually collapse and form stacks either side. An example of these landforms lie in the northern part of Vancouver Island, called the San Jose Bay. Over the years, the ocean has eroded the surrounding rock to reshape the entire landform. As you can see from the placement of the standalone rocks on the shore, there is clearly a landmass present millions of years ago. Through the gradual force of waves breaking down the top and bottom rock areas, the beach now runs further inland since the land has been eroded further back.